CCCR, or Centre for Creative and Cultural Research, investigates the ancient, innovative relationship between social culture and creative production. Based in the Faculty of Arts and Design at the University of Canberra, we generate scholarship and artwork in a wide array of humanities, social science, applied and creative disciplines. You are listening to a fresh presentation from the CCCR's Culture and Creativity Seminar Series. To learn more about the Centre's work, please follow the links in the program notes. This podcast was recorded on the unceded lands of the Ngunnawal and Ngambri peoples. Hi everybody, my name's Paul McGee. I'm the Director of the Centre for Creative and Cultural Research. Delighted to see you all here today. I'm going to start by acknowledging that we are on the unceded lands of the Ngunnawal and Ngambri people. I want to pay respects to all Aboriginal people present here today, all First Nations people as well, and to all elders past and present. Now, today it is my pleasure to introduce Sam Tomkins, who is a nationally awarded industrial designer and educator. Sam's practice centres on the possibilities of technology as tools to address the contemporary challenges of waste and overconsumption while exploring new object typologies. His current research explores robotic additive manufacturing paradigms, composite waste recycling, and localised manufacturing. Sam's going to be presenting with Max. Ian Maxwell's research interests operate at the creative overlap of computational design, material and fabrication knowledge, with a specific focus on integrated design processes that harness decarbonised material streams and automated fabrication methodologies. The recipient of multiple international and national research and design awards, Max is also an expert panellist on the ACT Government's National Capital Design Review Panel. So please join me in welcoming these guys to the floor.
We'd also like to begin by obviously acknowledging the Ngunnawal and the Ngambri people where we live, work and practice, and pay our respects to the elders and creatives past, present and emerging. I'm Max, I'm in white, Sam is in black. I'm from an architecture background, Sam is an industrial designer, product designer. Today we're going to talk about the work specifically we do together. Obviously we have many lives, but we've really spent the best part of the last 4 years since, or 4.5 years since both of us really, well, I guess you were here a little bit before then, but I guess we both found a common ground between our interests, and we've been working in a collaborative model since then. And I should acknowledge that there's no one in the audience who we are. We're also working with some other players, I guess, but for us, our model has been to pursue quite small grants to help fund the infrastructure around our research. And we've had particular success with City Renewal, a couple internals, and also with the Alistair Swain Foundation. That initial work is usually around the kind of scoping studies, paying for infrastructure, developing tools and techniques, which then spawn a range of kind of the middle space, which is the creative outcomes, which I guess are for us the demonstrators of the research that we're doing. And then finally, we formalize, I guess, the knowledge contribution through more traditional outcomes like journals and the like. I guess for both of us, we're really fascinated in the ecology of production and exploring the channels and the reciprocal networks and feedbacks between what we would discuss as the principal spheres of influence in design. Obviously, disciplinary knowledge, know-how that's accumulated over a very long period of time. But as both makers, we see that the materials and the experimentation and the properties of materials is the key agent in creative work. And of course, the means of production, the systems of fabrication. So all of our work addresses each of those three spaces, what we call a design matter system. So really what that means is that we're interested in generative computational techniques, so algorithmic parametric modeling systems. We're interested in the generative description of things that underlie and make other things, so the tools. We're interested in the deployment of computational systems for analysis and optimization. We're interested in developing computational frameworks that explore topics that are both simulations of known statistics and data, but also the speculative imagining of those data. We're interested in employing new technologies and techniques to revisit traditional older ways of making, ways that for reasons of labour or economies have been dismissed. We're interested in working and tapping into the material agency, so working with, not against materials. We're interested in demonstrating that materials can have multiple lives, second lives, and showing the social and cultural value in doing that, so dealing with waste streams and emergent material systems. We're obviously interested in creating highly bespoke tools that can marshal the agencies of the digital and the material worlds and underpin new ways of production. We've been increasingly looking at the lens of material culture as a way to do that. So material culture, obviously from an anthropological position, is the study of tools and that tools have meaning. And more importantly than that, they evidence the presence of a human intelligence at the moment of the creation. And I think in disciplines outside of design, it's very commonplace to accept that a tool actually is a rarefied object. It is not just a utilitarian device, right? That there's a cultural and an ecological dimension to tools, where in design we're not as versed as speaking at the means of production. So we, much like that of material culture, would suggest that design tools define design. And therefore their close examination becomes a really, really important part of our practice. And similarly, that they evidence a very specific form of design intelligence.
Yeah, thank you, Max. So today we're hopefully trying to express this approach that we take through two case studies. What links the two case studies is the overarching sort of methodology and framework that we've employed in these investigations. This is the cradle-to-cradle methodology that we follow. This was developed and popularized by Braungart and McDonough. This was all about understanding materials and the way that we interact with the world as not just materials, but considering them a nutrient. The way that we can divide up materials in this way is to this one idea of a biological nutrient, something we can deeply understand, the way that nature has always sort of worked in this material ecology. So this idea of a biological nutrient where it will have certain properties, it will have a use, or it will have a life, and at the end of it, it will be metabolized and broken down and then recirculated back through. In the materials, in the way that we build things in design, there's these other things that we can define as technical nutrients. These are things that we can't be broken down by these biological processes. So things like metals and plastics, sort of these human-created materials, we can define as these technical nutrients. So ideally, we can consider that the best way for us to proceed and have abundance in a planet with finite resources is to consider the materials as nutrients, all part of a cycle. So this is really what sort of underpins the work that we've produced here today for these two case studies. So these are sort of the broader themes of this cradle-to-cradle methodology. It's not just this idea of nutrient, but it's about the idea of circular economies, about our approach to consumption, and the approach of waste, and waste as a construct rather than just a result, and the idea of decarbonisation of our economies, the health of the materials that we are using and how we treat those materials, how we can make them less intractable by not having them bonded together in a way that they can't be pulled apart. And we consider things like the localisation of manufacturing, how we can make skilled economies that can be embedded in these manufacturing paradigms. But really at the center of this is the idea of the making culture through this idea of a culture of making and being back in touch with that. And really, what is the notion of craft in a digital age as well? So is it the creation of physical tools or digital tools, and the craft is associated with that? So I think we'll start with RePete. RePete deals with this notion of a technical nutrient. So if we're starting with material as the foundation of our investigation, then we consider that first and foremost a nutrient, and then we can explore further. So RePete was the winning commission of the 2013 M-Pavilion chair competition, an international competition.
22.
Sorry?
22, 23.
Oh, sorry, 22 into the 23
Not
season.
13, that was another lie.
No. So this is RePete. RePete, this is out in the wild throughout the 2022-23 season. Over those months, the M-Pavilion is an architectural commission, and alongside that commission is the production of a chair. So once we had seen Allzone's winning entry, Allzone Malaysian-based architectural firm.
Hi.
Thai-based architectural firm. Their winning entry was us to respond to that entry for what would be an aligned chair object that could host that event. There's a few key things about that. We're making an event chair. We're making a chair which has a very determinate lifespan of its use, which sort of speaks to what confidence we can have as designers for what we believe the life of our products can be. So we'll kind of unpack a few of the themes around the material expression, the idea of machines and machining, the associated craft that can bring tools into the world and afford new design opportunities, the materials associated and what the impact is. So chairs, like all objects are really these containers of culture. What they do is they contain within them the aspirations, the values, and then the technologies of their time in a social and cultural sense. And chair is no exception. It's a wonderful expression throughout time of what we are trying to achieve through the objects that we create. There's always going to be some ambition of creating a new chair. They're no mean feat to create one. I would almost refuse to do a chair. They're that difficult. But throughout time, you can see here that we have, starting with Marcel Breuer's chair, the ambition of the time with modernism is the removal of what is unnecessary, the removal of ornament, and almost what can we subtract from this archetype until we have left sort of the essence of the object. Marcel Breuer's ambition here was, well, the best chair that is of the minimal materials is simply air. So how close can we get this idea of sitting on air? And his idea, well, I can remove legs. But the technology of the time, which is bending steel tube, this was a new and emergent technology which afforded Marcel Breuer to create the Kesker chair, which allowed for somewhat of a sense of this. Moving forward, we have Ray and Charles Eames' work with the material of plywood and the ability to manipulate an otherwise, quite linear material into these sort of complex and beautiful curves to create these sort of elegant expressions of that material. Moving forward to Colombo and Panton, the idea of moving into these petrochemical plastics and creating materials that could take on other forms and material expressions that we hadn't seen before in this space. We get to Vernon Panton's chair, the first one piece, this mono-material object of one continual surface that creates the form of a chair, expressing not just new materialities, but new formal presentations of chairs. Then we also get to Robin Day, the idea that these beautiful examples of what chairs could be, introducing the key theme of the time of democratizing design, not having these objects that belong only at the upper echelons of society who can afford it. So how we can actually make the Robin Day chair, which in the 80s was this idea of beautiful high design that could be sat on in a primary school context. So chairs are this wonderful thing that sort of shows us how we can present sort of those challenges, those ambitions of culture through the idea of our products. All right. So unpacking this idea of machine or machining, we start with this ambition of creating a chair that can respond to this technical nutrient from the M-Pavilion. Now, the kind of one of the core, I guess, agendas of industrial design is this idea of mass production. How can we take something that would be otherwise artisanal, very time-consuming to produce, and how can we automate those processes so we can make one chair many, many, many times? The drawbacks of these sort of traditional ways of making these products and amazing processes such as injection molding requires the necessity of molds and tooling. The idea of creating the negative of a facsimile to produce the actual object in itself. You get wonderful, repeatable results. However, you're sort of stuck with that particular mold and with that one particular design. So there's no downstream changes that we can make to our mold or our design without the consequences of a new tooling or a new mold paradigm. So for us, it's all about how can we create tools that can afford new ways of making? How could we make a chair that doesn't rely upon the expensive nature of tooling and the expensive nature of all these mold making processes and have this sort of direct approach to manufacturing material into product with no additional waste associated. And so this sort of the idea of tool making extends into our practice where we're trying to build the tools that actually create the designs. Here you can see this is Yuri, our robot arm, and this is Uzi, a bespoke extruder that we've made here in the workshop. You can actually see our value proposition of our funding, exactly where our funding ran out to get the juice bottle to fill up the reservoir of the plastic pellets and the recycled computer fans that from the discarded computer. So there is an ethos that carries through. And I think that's also what's kind of key maybe about this Australian way of designing as well. This idea of geographic isolation, which means that we kind of get with what we can find. In this case, a 2-litre juice bottle that was nearby. So this is the tool that we've made to realize this design. So you can kind of see here that this approach means that the upstream changes to a design can be immediately enacted. So we start in this sort of parametric world of design where we can control and modulate and configure a particular design. In this case, the M-Pavilion chair. Then there is the instructions that's given in a computational space, and then it allows us to create that new chair. So any change that we make upstream is immediately downstream. So without any necessity for any additional materials or resources thrown at the process.
I think it's worth observing that the concept of tool there is encompassing the actual digital tools and the material deposition device, the thing you might more traditionally call a tool. Every step is bespoke. Like there's no off-the-shelf anything there, right? It's all developed specifically for these projects. And we love the robot because gesturally it's very similar to the human body, but it has no functionality. Like it cannot do anything. It has no hand. So we think it's the best form of tool because it actually can't do anything. So that forces you to invent an understanding of how you want to deploy that tool. And then you backtrack your computational processes to do that. And I think the other thing, which is because it's as much about software as it is about hardware, every chair can be different and there's no penalty, time or cost, because your processes automate all the translation steps in between, which is something that perhaps in both the product design and an architectural world is rather different, because we've obviously had this investment in like a drawing as a translator of information between a form, a fixed finite form, and a million replications in a product world, and maybe a 1 or 2 replication in a building world.
Thanks, Max. And so, yeah, and so you can see here, this is Uzi and Yuri printing out one of the M-Pavilion chairs. There were 50 in number, which this process afforded such a small scale run, allowed us to actually create this product. We are sort of bound by the process in a way. So it's sort of formal properties come from the sense that when we print this object, we can't start and stop the extrusion process. The robot will need to continually move in a continual path. And so really what we call super tubes is this process can really only afford itself to tubes, continual spirals in the way they print. So we're bound to that process. And so the form is dictated by the process in itself. It leaves its thumbprint not just in its material qualities, but its formal properties as well. So you can see here, this is sort of the benefit of this low production run. This product, first of all, can't be produced by those traditional methods of injection molding. There's no way to get a tool inside of this to form this. So first of all, it can't be made by those processes. And also, if it were able to be made by those processes, it would be so cost inhibitive, it could never, ever take off the ground. So it's also the idea that if we're doing this, we manage to shrink our factory in a way. That is our factory that produces our chairs. You could fit almost in a phone booth. So it's the idea that we're shrinking and localizing the manufacturing. The only thing that's brought to it is the material. So we're kind of thinking about a paradigm of factories being localized and portable and able to move where material is or where the design is deployed, reducing its impact further. So the craft of this, did you want to speak to the craft?
Yeah, we probably should hurry.
Oh yeah, sorry.
We didn't obviously practice. We didn't even show his slides really, so we're going to have no timing. I guess for us then, this question of craft, which is revisited, and craft is always an active skill between user of a tool and in constant feedback with the material substrate through which that tool operates. So for us, I think there's a really interesting, we do consider digital craft as a form of craft. Obviously, it has a different set of dimensions and qualifications around it. But for us, we're very interested in the feedback between the material and the digital design component. So in this particular chair, it's about tuning the distribution of toolpath waypoints in order to maximize the environmental qualities of the chair itself. So the way that it takes on light, the way that it refracts. And for us, that was a way of contextually responding to the pavilion itself, which was made up of fabric, and it cast actually spectrums of light. So it was a slight orange and red tones of light. So for us, tuning the tooling, constantly prototyping, moving backwards and forwards, is that exercise of craft. That is the equivalent of operating a chisel and going, well, there's a bit of a knot, I might do something a bit different there. And I guess that's the difference between traditional production, which is like you're just in massive volume pumping out 100,000 units, that actually removes character in order to enable the efficiency of that means of production.
So returning back to this idea of material as nutrient and back to this idea of cradle to cradle, that form of production produces a chair. But at the center of that particular project was all about this idea of material as service. So the idea that the material and the objects that we couldn't create, we can consider them more as these functional reservoirs of material that hold the material that we need until we no longer need that particular object to do that role. So it deals with the finite nature of materials and sort of the, I guess, the ever-expanding requirements for new things and new ways. So what you can see here is repeat and what has been dubbed re-repeat or repeat repeated. What has actually happened here is that we've utilized the material as a technical nutrient. We've produced repeat in this way. It has a life as a product providing value to our lives. It has a service life. And then the ambition is it could be recovered by those who sell the product or offer the product, and then we can reutilize that material, whether to make the same thing again or whatever the new object is required from a social perspective. So these, in this case, these are the obsolete stools. Some of these are the function of prototyping from trying to develop this, but the vast majority were the ones that didn't completely endure the M-Pavilion period. It was a small amount that was returned back to us after some very enthusiastic festival goers might have damaged them.
They served alcohol at a lot of their events.
Yeah. So these ones which are almost what we call hotel lobby proof. There's only a few that came back with a few cracks, not completely destroyed, but it offered us an opportunity to realize the ambition of the project and put it into practice. This idea of an object going out into the world designed in a way so what it could be returned and turned into something new. So what we have here is we've taken the leftover components of the previous M-Pavilion chairs that were either damaged or in a state of disrepair. We then granulate the material and turn it back into recycle it. So it's all washed and ground. And then we go ahead and repeat a bit of experimentation into removing things like moisture that can get into the plastic that affects the process. And you can see here that there is a slight color change as a function of our slightly ancient granulator being a bit rusty, right? We call it circularity bronze in a way. So you can see here, this is repeat, which communicates that we can still not just recycle materials, but we can also cross-cycle them, maintain the esteem of those materials in new products, not just something that is considered to be low of esteem or of lower value or of kind of a lower echelon because it is recycled, a big problem of which we're dealing with in the world of product design.
Well, it's a massive problem in recycling culture. There's actually very few examples of material recovery, in which at the moment around 80% of materials from commercial fit outs and buildings are recovered, but almost none of that material has an increased value, cultural or economic, right? There's only downcycling. So we would call this cross-cycling because the second product is of equivalence to the first. So I don't think we've demonstrated an upcycle, but we think that it's still, a cross-cycle is still a rarity in recovery industries.
So I guess this is the impact of repeat. It was fairly well received. I think we can argue we were recipients of the Good Design Award last year. We got gold in the product design category, along with other international and local accolades as well, including the Excellence Awards here as well. This is also now in the permanent collection of the Powerhouse Museum, alongside some of my heroes as well. So SuperFlax is the sort of the other side of this. We have our technical nutrient and we have our biological nutrient. So SuperFlax is a response to the National Gallery of Victoria Australian Furniture Design Award Commission, and we're commissioned to produce this piece. So
it's a two-stage process. The first is blind. It's a design and a component where you respond to the 5 themes essentially of the commission, which is around disruption of status quo, so material or procurement. It's obviously around aesthetics. If I had my notes, they're all in there. New forms of expression,
logistics,
sustainability, manufacturing. So then five pieces are selected and then commissioned for the Melbourne Design Week, which took place in, was it May? Yeah. So this is all done this year, I guess, this one.
So breaking it down into impact, expression, material, machining and craft categorically, it was commissioned and was in the top 5 of the Australian Furniture Design Award. and is the winner of a nationally awarded but redacted for embargo reasons.
So in 4 weeks, we can tell you some good news.
Yeah. So the expression, the material expression of this and the expression of the way in which we've made it all starts with this nature of knitting. And again, going back to these cultural containers, the sort of abstract notion of sitting on air realized through the Keska chair, RePete, which is all about the dematerialization and rematerialization of the object as a technical nutrient. And then there was this piece that we were commissioned to produce for the National Museum of Australia, part of Material World, where they were looking for a candidate for a glass category that they were going for. There was glass, leather, metal, and I think wood. And so our response was, well, we're interested in glass. We don't have a huge amount of experience with it. And so we offered this bold suggestion of a strange way in which it could manifest, which is what happens if we tried to knit glass? And so what we produced here is vitreous knit, knitted from a glass fiber and formed and cured into that location, responding to this idea of porosity and sort of the compliance of glass, which we might not associate with it. So, so we went through SuperFlax, which is where that was the beginning. This idea of knitting had kicked off, and how perhaps we could scale it from a small artifact all the way up to maybe a furniture piece. And so this is the approach that we set out upon for the Australian Furniture Design Award.
Well, we're a bit silly because we promised to make a chair and we needed to make a knitting machine in order to make a chair. And we just thought, how hard could it be to make a knitting machine? Stupid.
So Max, if you want to speak to the material that we've employed here.
Well, and I should say at one point, we thought we could use, so a knitting machine like this would cost $500,000. UTS has one and we were hoping we would use theirs. Unfortunately, the gauge of material was too thick for such a machine. And RMIT has one, which is worth $2 million. But at that time, we weren't friendly enough to use theirs. So we had to then make our own. So I guess in reflection of vitreous knit, we knew at the time that it was a very interesting technique. We knew that it had a lot of formal possibility, but we were not particularly comfortable with the material system used. And obviously the material system in that case was not only glass fiber, but the resins, petroleum-based resins. So we really set our challenge for SuperFlax to produce arguably one of the first chairs that had zero petrochemicals. And that was in all aspects, both in terms of the fibers used and also in the resins, the plant-based resins that we would apply. So we went hunting for a material, and obviously within the culture of making on this continent, in fact, on all ancient continents, is the use of endemic herbs, such as flax, for the creation of a whole range of functional objects, from bags to dresswear to everything, really. What's really, really interesting with these herbs is, unlike things like cotton, which we also use in textile industry, that they are ethical materials. So they're indigenous to all different continents. So they come in a whole range of different forms. And they're healthy for soils, which is a significant difference to obviously most of the crops that we farm, right? So we obviously zeroed in on this material. We set about exploring a range of different industrially produced. We eventually found a material which originates from Canada. So its footprint's not as small as we would like. And we know that there's obviously sufficient evidence for uses of lamander and spinifex in Australia. We just, within the confines of this particular project, couldn't procure a material that, let's just say that's ongoing work. And we're actually working with a Darug elder in Sydney at the moment on exploring the use of native grasses and the like. So our reference point was obviously vitreous knit, and then the $69 machine from Lincraft that we used to make that. I still get lots of emails from Lincraft with specials. And this is, I guess, where the kind of collaboration really pays off. Sam's an amazing toolmaker. And I'd say my strength is more on the digital side, and we're both fascinated with the making. So Sam's challenge was to take a $69 prototype and make a bigger version. And I guess the two precedents we had were in the 19th century, the use of sock knitting machines, so a very simple mechanical device. And then, of course, through a parametric model undertaken in Creo to basically scale that as a system, but to go through the myriad of processing and all the different components, which are all 3D printed in Workshop 7, using recyclable PLA or polylactic acid plastics. Do you want to contribute?
Yeah, I mean, speaking to tool making, the answer to how hard can it be to make a knitting machine is immensely and nearly soul breaking. That's the answer to that question. So this, and it's when you, and I'm a complete tourist, not even a visitor. I'm a tourist to the world of knitting. And, you know, when I set out on this, it's a deeper appreciation for a craft that I'll never understand a fraction of the knowledge of that. So as a tool maker, this was an immense challenge to create. There's 140 knitting needles that were required to get the size we needed. The nuances of thread gauge, the nuances of how fast, how quick we could knit, how dense we could make are all a function of sort of almost imperceivable properties that typically with knitting is sort of done at a sensory level, something that's very difficult to replicate in a machine. So set out and produced this knitting machine. Which is some way can be open source in the sense that someone can take this digital file and produce one for themselves, which I'd really reference that open source community. There are knitting machines out there that are 3D printed to make socks. So I really leveraged that amazing open source community for how I could kind of scale up my own. So this was produced. There's about 300 to 400 parts involved in the production of it, and many iterations to try to get the thing to actually work. Under certain time pressures that I was afforded.
It's pretty crazy time pressures. And I guess the crown itself has had 6 formal iterations that we've actually printed and tested. And that time of testing is really, really important. And you know, it takes an hour and a half to basically cast on, to then run a 10-minute test, to then another hour to cast off. That didn't work. And then there's a day to print new crowns. So when we had a production time of a month, and you basically spend more than half of that freaking out when things aren't working. But I guess that's the half empty version. The half full one is, of course, as we've said along, that tools hold knowledge, that once you have a physical manifestation of that knowledge, you then can pass that on. And I guess for us, that manifestation is both a digital file, which Sam's alluded to, can be open source and shared, to obviously now there's a piece of equipment, which, you know, most people would pay $500,000 for that. What did we pay?
About 300. Yeah.
I mean,
sort of Linkcraft email. So,
and then the skateboard bearing. So we no longer have a skateboard, but we do have a knitting machine.
But it is a technical nutrient. If I need my skateboard again, they can come off. So that's fine. So this is the bespoke knitting machine. It knits a very large 650 mm diameter sock. There were 3 socks that were to produce SuperFlax. The 2 internal cores are a raw material. And you can see here's all some of the components that were produced.
40%.
That's about 40% of the components that were required. So this is it. So introducing this is SuperFlax. SuperFlax, 100% linen flax. 920 knitting minutes. The single thread length is 3.7 kilometers. So if you took one thread, took it down to the foreshore of Lake Ginninderra and came back and did that again, you would have the length of the thread that is inside SuperFlax. It is made from a 100% bioresin, which is a fairly innovative product in itself, which means that the composition of the flax with the bioresin creates a completely bio-inert composite, which is not something that we can achieve through the high-performance composite world of carbon, Kevlar, and fiberglass. And so here it is here, SuperFlax. I mean, the challenge here is the idea of formwork. We've created an inside-out object. The challenge in itself, just to make a machine, to make the sock, is one thing, but how do you take a sock and give it structural and formal qualities? And that is sort of the idea that there is not just the idea of making tool, but the idea of making jig. So how can we actually make a jig that we can stretch these socks over, hold them in position, apply the bioresin to them, and then ultimately remove that formwork to ensure that we have a monomaterial approach to our product. So there is no internal structure, there's no internal skeleton. It is both skin and skeleton in one.
Yeah, so it's interesting for us, and we tried when we did the Furniture Award to present, we wanted to exhibit the machine. We were also kind of keen to exhibit the formwork. And arguably as makers, we were more interested in those 2 things being exhibited than the chair, sort of. Just because, again, it's this idea of where is that skilled system. And for us, I think, you know, there's a number of versions to do the formwork. System that collapses and comes out the nose hole of a chair that leaves no trace behind. We think is a real strong demonstration of a digital craft. There's a parametric model which elaborates the formwork. So as we design a chair, we're designing the formwork at the same time. There's a relationship to the associative model for the knitting machine. So when we began, we didn't quite know what the stretch property of the woven textile would have. So how big did that machine actually need to be? I can tell you it was 3 days before it was due, 2 days before it was due. The documents were due 2 weeks before the actual thing. So we exploited that shipping window a lot. We thought that we had knitted 2 textiles. So we thought 2.3 kilometers of material would be enough. And then when we stretched it, the look on our faces when it didn't stretch as we hoped meant that we needed a 3rd knit. So we were in a kind of crisis mode. But that's this importance of feedback and of prototyping. And really that's part of our research, is that in developing new tools, there's going to be a lot of failures along the way. But responding to those failures and embedding that knowledge within the digital model or in the physical artifact at the end is that constitution of a craft, and equivalence, I guess, within a digital context. Yeah, so hopefully we've left some time for some questions. But yeah, I guess in a way for us, we don't focus on objects. We focus on the space between an object, the material experimentation, the methodology, the production systems that go to making it. We think that's the space of innovation within the context of our design disciplines. We place equal value on all of those. Depending on the example on the floor, sometimes the material system and analysis of the status quo of how those materials are used and what those problems are. Generally, those problems align to questions of greenhouse gas emissions or economies of production, which lead to a loss of character. So we try to attack those things. But to do that, that means we really need to touch each of those 3 spheres of influence in order to prosecute our work. Yeah, so hopefully the overview was sufficient today to kind of lift the hood on things that we're interested in. And obviously we're super interested in working with anyone who, Mike's come. So we're obviously doing some great work with Mike and Sally. I saw come as well at the moment. So cool.
Well, extraordinary presentation. Guys.
If anyone would like to make any comments, ask any questions.
This one.
How long per chair with your little robot arm and your Uzi fella? How long did it take per unit?
Well, I'm really happy to. What I wish I had here was the tiny prototype that I printed as a form study. That form study took 5 hours, about 6 hours to produce. RePete here takes about 1 hour and 50 minutes. So oddly, the 1 to 5 scale model takes 3 to 4 more times than the full scale 1 to 1, which is what's amazing about this process, that we can actually put so much throughput of material.
It's actually interesting because we generally don't like to think of like mass or even medium production. So for us, it was a really big challenge to get consistency of outcome, actually. And then I think the chairs ultimately went to M-Pavilion with 2 hours 43 because we wanted to tune the thickness, which is indexed to how fast the robot's moving between its waypoints, and obviously the geometry and the nozzle. But yeah, when we moved from one part of the workshop to another, the temperature shift between those 2 rooms had a pretty significant consequence on the object. Now, normally in our practice, because of the automation from design model to physical outcome, we've never actually really had to do many of the same thing. So those questions of consistency have never arisen, actually. And even in the space of 3D printing and robots, which is a more common, certainly of the 2 objects here, like no one's doing that. There's a few people around the world doing this. But even the research, no one's really looking at that because this kind of idea of local manufacture is not really something that people are kind of engaging in, just because of the opportunity, I guess.
Can you hear? Absolutely blown away by your work. I think it's fantastic. I'm a social scientist. I'm interested in people. Okay. And the 2 questions I have relate to people. First of all, the dumb question, most of my questions are, how do you know it's comfortable? Right. From a design perspective. And the other question relates to the role that people have going forward as an industry, as a craft, as even a digital craft. they're not presumably going to do people en masse around the world are not going to do exactly what you do as researchers, but they will do something. Could you describe what they will do with your technology? Thank you.
I'll field the first, you field the second. Yeah, how do we know it's comfortable? I mean, I think that it is through the experience of a designer to sort of understand the properties of what is the right height for a chair, what is the the right size for it. When we were presenting, where we were presenting that, once we knew that we'd won, we were secretly sitting on our chair at the time, so they were thrilled that it could be produced. But we actually knew that there's a lot of sort of talk around as comfortable as a bus stop is sometimes what is thrown around as an appropriate comfort for a stool. But that's because it's quite a rigid material. We knew that the material compliance that we get from the fact that it actually has a bounce to it affords people not just to sit there in a rigid platform, but actually have some movement and compliance.
But within your process, do you actually test that?
Yeah, I mean, we do test in that. I mean, the good thing is that because we're dealing with a surface at a certain elevation, we can actually pretty easily extrapolate that from those things that exist. We can take any sort of chair with a similar property and understand how close we can get within a range.
In the digital space, we're not doing anything fancy. We're not doing analysis or stress loads and stuff, even though the software we could have. We just print a bunch. Yeah. And we sit on them basically. So it's more empirical testing in that sense.
Not bad.
But yeah, your bum's a pretty good measure, I think, of comfort. Obviously, these are not full backed chairs and stuff, so there's a limit. And the M-Pavilion at the time, I remember they did want us to look at one with a back, but we were actually more worried about people reclining in it, slipping out. We weren't sure what the floor was and stuff. So yeah, obviously our professional indemnity insurance was on the line. So, and then the second question was,
it's really about
what do people elsewhere learn from this? Was that
well,
the question?
Can you see an industry going forward of people who are not researchers but using this technology in order to produce? What does it look like?
The plastic extrusion is definitely a thing. There's a company in Spain, Nagami, they have about 64 robot arms right now. Manuel's is finishing his PhD at RMIT, but it's literally in the business of 3D printing. There's a couple companies in Denmark and things that are basically exploiting this technique or techniques equivalent to. I think for sure, if you look at Canberra Uni, we've got nothing. We have a $20,000 robot arm and a $500 part. So we kind of subscribe to this hack approach. And I really think that's very low overheads. I mean, that is definitely something that your person shed or your community could take on as a venture. So yeah, I kind of think that world will overtake the other world, and we'll just be going onto a warehouse online and downloading files and printing. Whether that's a good or a bad thing, I'm not sure, but maybe a different set of questions around ethics and IP there. But yeah,
I might just make a comment following up on that. While you guys were talking, I was thinking of the physicist Karen Barrard. She wrote a wonderful book called Meeting the Universe Halfway, and she's talking about the use of experimental apparatuses in scientific experiments. And she makes the point that, at least with the work she does, you're always designing a different set of tools, a different apparatus for each different experiment. It's not as if the tools are just a kind of inner input, but rather that's actually part of the process of investigation, is making, the very equipment that allows you to be objective, if you like. So yeah, just wanted to, see what you guys thought about that in relation to the way you've been talking about tools.
Yeah, I think one thing that worries me a lot about the use of robotics in academic research is, and a lot of it's coming from Germanic countries as well. And, I'm half German, so I'm allowed to say that. It really centers on, I guess, still a 20th century understanding of the machine as an optimizing device. And a lot of the research is centered on really, really hard questions, but around predominantly those related to reduction, optimization. I think we take a clearly a different point of view. There's no chance of our use of robotics replacing human labor, right? In fact, we spend way longer because of their use than if we excluded their use. So we're actually interested in the affordances of those technologies to create what we would like to think of as culturally rich outcomes that are enhanced by the use of technology, not supplanted by. So, when we talk about, we showed some images of technology to revisit old ways of doing things. Those old ways of doing things have been dismissed only on the grounds of economy, of labor, and of, the cost of humans, basically, and then because they weren't beautiful, endearing objects, right? So that's our interest as designers. We want to maintain the kind of human quality of object, the material quality of object. And if that means we need to marshal new technologies to do that, we'll do that. And I think that is a point of difference in the work, is that at no point would we talk about efficiency. Like, that for us is an irrelevant criteria.
Yeah, thank you.
Thanks for your presentation. Fascinating work. Nice to hear about it after looking at it for a year or more. Look, with the flax chair, I mean, it's made from a sock, so presumably you needed the third sock because just having two didn't afford enough sideways stretch, or was it lengthways stretch that you're talking about? Structure, so not enough material.
Yeah,
okay.
It's not. I think this was what I was talking about that one. That's one being recorded. Yeah, so the interesting thing with the laminate of sock, and this is, again, like the one thing we have at UC is a lot of knowledge, like Bill in the workshop's incredible. Because we're knitting quite a heavy gauge twill, much heavier than a normal machine can do, when you laminate those layers, it's actually the knots create space between, which then the resin fills, and you actually make almost like a bone-like trabeculae structure. So it actually, the more layers, actually gives more air between the layers, which becomes cast through the bonding process, which gives it its structural performance. So it's not a linear graph, like one more sock will give you this much more. It's actually like that.
Which leads me to my second question also about structure. The shape, the cross-sectional length of it, I suppose, obviously is very similar going along because it's from a sock, right? So is the shape got to do with its rigidity? So like, why didn't you just print a square tube, and why is it that shape, I guess?
Okay, happy to answer that. The what is kind of one of the threads that moves through. I got to stop saying threads with knitting, but one of the threads that moves through from RePete to here is that the Vernon Panton chair. It's the idea of that single material object not requiring additional legs or a subframe or a structure. It is a single skin that creates the object. So the ambition here is that if we make box, then we actually have racking. We don't get all of the strength and stiffness from compound curvature. So that's why there's not a straight line on really either object, because it is that curvature that provides all the stiffness and rigidity. And so in a way where not just we're constrained by a single profile that needs to be changed and manipulated throughout its length, we're also sort of stuck by the fact that we can't adjust stiffness. We can't adjust thickness in a localized position. So it's the idea about this single tube and how we can construct it in a way that it can be structurally sound.
There's also that idea of collaborating with the material. So textiles behave in very unique ways, especially as an architect, in comparison to the materials we would use. So we always say concrete's wonderful, plastic, full of greenhouse gas emissions. But the thing we make concrete first is a timber form, which has none of those properties, right? So there's this massive gap between the will of one material and the possibility of another, right? So here, the unique thing is that this entire chair is designed, it's controlled by 4 boundary conditions, those 4 edges. And by putting them out of phase and we let the material do the computing of shape itself, we simulate that, of course, but we just let it do its thing, actually. And that's what fabric wants to be. So in a way, we would, and it's interesting, a lot of people don't like the shape. We do, but that's okay. That's a subjective comment. The nose cone is deliberately done as a way to increase performance, stiffness, structure at the ends. That makes a huge difference to the performance of the bench as a whole. But yeah, a lot of this is about just expressing the will of a textile, which is quite unique, right? So really, that's our interest in those geometries, right? Is just to let fabric be fabric, do what it wants to do, and harness that to produce an outcome. we're not that happy with the flat bit. We wanted it to do this, but next time around we can fix that.
Do you ever see a world? So I'm just sitting here and not particularly comfortable in this chair, and I go to Llewellyn Hall and I'm definitely not comfortable there. And I go to most university lecture halls and I cannot be more uncomfortable. And what's happened with the mass production stuff is that it's my size, so one size has to fit a range of people. And I'm just wondering the other way around to look at this question is, rather than having it mass produced, is to have it locally produced. And so you could perhaps, for example, in my house, you could scan my bum and you could put that in the top end of the design, and then you could build your structure, and then you could have a disintegrator in the next room. And, as I go older or my kids grow bigger, we can make a new design. And that allows you to have a local production without having to have the horrors of these chairs.
Yeah, I mean, and volunteering for a scan, I assume that's what I'm hearing. So I think
So just to finish it,
Yeah.
and that's what the whole artisanal stuff was about. You had it locally knitted, and when my girlfriend used to knit me jumpers, she'd carefully measure me and she'd knit the jumper and stuff like that. And so she would scan me and then she would knit it and stuff. So what I'm trying to suggest is, and I'm the last person to talk to about design, but the concept always was about the end point. And what we've got is one end point for 5 billion people.
Yeah, I mean the end point is a function of inputs. So if we're thinking about we're producing a chair for a group of people as a market, we're bound by that mold. That mold dictates that that's what the serialized object would be. But with the paradigms that we're exploring, they're mass customizable. So there's no necessity from an inputs perspective that needs to be one input. If we need scan of X many backsides, then that's what can afford that many objects. So we're really not bound anymore by having one object to fit some or nearly no one.
You and Eddie are working on that exact problem right now, aren't you?
We're working on in this problem in a defense project for the idea that protective equipment fits none. It's designed in a way that fits some in some capacities, but we're kind of dealing with the fact of what happens if we can control the inputs of the anthropomorphic fit, the gooey blob that we are, in a way that each one can be its own. So I think we're moving into a wonderful space where mass customization can start to overtake this idea of serialization and the compromises associated with it.
Hey guys, we probably should call it time then. That's a beautiful point to end on. I think that's a pretty resonant kind of promise for where this stuff can go.
No,
Oh, yeah.
you promised to scan a butt and to solve the world's problem. That's how it ends.
That's how it starts, yeah.
Please join me in thanking these guys again.